Hi, Riley. All right, last one here, page 3. All right, it looks like the first one you had questions with was this salesman word problem. Okay, so 60 dictionaries. If the quantity is 60, the price is 18. But then it's saying that if he reduces the price by $1, he would sell 6 more books. So that's what's happening here. So we're going to try to figure out some things. It says give 2 points in the form PQ. In other words, the P value is going to give a price, and the Q value is the quantity sold. So we know from the first sentence, we know 1 point. We know that when the price is 18, we sell 60 dictionaries. So that's 1 point. Well, let's just find another point. It says that he would sell 6 more books if he reduces the price by $1. So let's just reduce it by $1. Instead of $18, we'll have the price be $17. And then what would be the quantity sold? Well, 6 more than 60 would be 66. Okay, so, I mean, someone could pick other points on here, but that seems the easiest to me, the 2 points. All right. Write a linear equation where Q, notice here, Q is standing for the Y value and P is the X value. So a linear equation is an equation of a line. We have 2 points, so all you're doing is going to be finding the slope and the y-intercept, or you could do point-slope form and then just simplify by solving for y, or in this case, Q. Okay, so finding the slope. So the slope here is going to be 66 minus 60, the change in y, over the change in x. Just be consistent. If we started out with the point with 66, we're going to start out with the x value of 17. So the numerator is going to be 6, and the denominator is -1. So we've got a slope of -6, which seems right, because if I'm increasing the price, then the quantity sold should go down. So it makes sense that it's a negative relationship. Okay, so if I use point slope, it would be y minus 60 equals -6, x minus 18. But, oh shoot, I shouldn't be writing y and x. Let's replace it with q and p. Same idea though. In this case, my output one is q, and my input one is p. And it looks like the professor wants you to solve for q. Yeah, so q equals -6p, 18 times 6. Let's see what that is, 108. So minus 6p plus 108 plus 60. So the quantity in terms of price is equal to -6p plus 168. So that would be part B, that linear equation. And now we're going to use this equation to answer C. It's saying how many dictionaries would the salesman sell if he set the price at 14? Okay, so let's do Q of 14. So it's going to be -6 times 14 plus 168. All right, what's 4? You probably have a calculator, but I don't have one handy. So it's going to be -84 plus 168. Let's see, 168 minus 84 is going to be so it is, 84. So 84 dictionaries. So I think, so let me just, a way to double check that is, so if the price is 14, that means from 18, I'm subtracting $4. So the number should go up by 20. Yeah, that's right. It should go up by 24. So 84 is right. Perfect. All right. So that is, that was question 10. I'm going to open up a different slide because I have no room to do question 11. So if you have it in front of you, it's the let f of x equal x squared plus x minus 1. And we want to put it in that vertex form by completing the square. And then we're going to solve for when y is 0. We're going to solve for the x-intercepts. What is x when y is 0? So let me open that up. I'm going to add a new sheet. Okay, so I'll review with you completing the square in case you forget. Okay, so the first thing I do, well, first I change f of x to y. It just makes it easier for me. And then I bring the constant term over. So I'm going to say y plus 1 equals x squared plus x. All right, so here's the completing the square part. You take whatever is in front, the coefficient in front of the x term. So that happens to be 1 in this case. And you're going to do a half of that coefficient. So a half of 1 is a half. And then you square it. So 1/2 squared is going to be 1/4. And then that's what I'm going to add. So I'm going to add 1/4 to this right side. But whatever I do to the right side, I've already also got to do to the left side, because I don't want to change the equation. I'm just rewriting it. So I'm going to have y 1 1/4 is 5/4 equals, and now this is a perfect square, and it should always be, since the sign is plus here, you want to factor it into a perfect square, it should always be x plus or minus, and that depends on what this is right here. It's plus in this case, so it's going to factor to x plus something. And it should always be whatever you got before you squared it. So it should be half of that linear coefficient. So it does make sense that it should be x plus a half squared. That's how this here would factor. All right, and so then just solve for y. So I've got x plus a half squared minus 5/4. So that is the equation in that kind of completed square vertex form that the professor is asking for. And then the second part, that was part A. Part B was solve for where this equals 0. So you want to solve for where x plus 1/2 squared minus 5/4 equals 0. There is absolutely no need to FOIL that x plus a half squared out. Instead, it's already in a nice form. So isolate that squared piece. And how do you get something out of squared? You take the square root of both sides. You just have to remember plus or minus. So x plus a half equals plus or minus the square root of 5/4. So you've got x plus a half equals plus or minus the square root of 5/4. Not over 4, sorry. The square root of 4 is 2. Over 2. So x equals 1/2 plus or minus root 5/2. That's the x values where that equals 0. Okay, all right, so that was number 11. And I'm thinking you struggled with 12C, which was graphing a piecewise function, which I feel like your class had trouble with last year. So let's look at that. I'm going to open up a new sheet. Okay, so number 12C. So that's graphing this piecewise function. F of x equals 3x minus 1 and x plus 1. And this is if x is less than 1, and this is if x is greater than or equal to 1. Okay, so the good news is you're just graphing lines. 3x minus 1 is a line, and x plus 1 is a line. And so the key, Riley, is that always start with the restriction, even if it's not included there. So what I mean by that is when I graph 3x minus 1, the first thing I'm going to do is plug in this restriction of 1, even though it doesn't have an equal to there. So because it's for all values until I get to 1. So when I plug in 1 for x, I get 3 minus 1, which is 2. So I'm going to plot the point 1, 2. But because it says for x less than 1, instead of putting in a filled-in circle at 1, 2, I'm going to put an open circle. All right, but since it's a line, I need one more point. So let's find another value to plug in for x that's less than 1. I would do 0. 3 times 0 is 0. Minus 1 is minus 1. And so the first piece is this line. And again, it's really important to plug that restriction in because it's the line that goes all the way up to x being 1, but doesn't include it. So hence the open circle. Okay, let's do the same with the second piece. Always start with the restriction, but this time because it could equal 1, I'm going to put a filled in circle there. So when I plug in 1, I actually get 2 as well. So it turns out that what used to be an open circle from the first part is now going to get filled in. That's not always going to be the case, but in this case, both pieces end up having the same y value at the restriction. So I plug in 1, I get 2. Let's plug in one more value. If I plug in something like 2, I'm going to get 3. 1, 2. Okay, so there's your piecewise function. It's composed of 2 separate lines. And you can see how it kind of looks, unlike a graph that's curved, a piecewise function composed of lines is going to look pointy like that, or like it has a corner. So important to remember, graph the restriction. If it's undefined at that, meaning doesn't include the equality sign there, it's an open circle. If it does include it, it's closed. Okay, looks like there's one more, 13. So I'm going to pause this so I can read 13. I haven't read it yet. Okay, I'm back. I read that 13. Okay, this is an interesting one. So I'm going to open up a new page here. All right, so you've got this car dealer. You can either offers a purchase option and a lease option. So you can either buy it outright or lease it. So if you buy it outright, it's actually, let's write this down. So if you buy, it's going to be $25,000. If you lease, you pay right away $1,200. But then you're going to pay each month $350. So we're going to say plus $350 times the amount of months. So if it's just the first month, it'll be $1,200 plus $350. 2 months, it'll be $1,200 plus $350 times 2, and so on. So the total amount paid is a function of months. So that's part A. So part A, it's part A here. Part A would be, it says find the linear function f of m that gives the total amount you paid on the lease after m months. So the total amount you will have paid will be the initial fee plus $350 times the number of months. Okay, so that's part A. Part B, with the lease option, after 4 years or 48 months, the car has a residual value of $10,000, meaning after 4 years, if you've paid this lease amount, you can then buy the car for just $10,000. The question is this a better deal, or is it better paying $25,000 outright and just buying the car? Well, let's see which one would be more expensive. So we already know the buying's $25,000. So let's see how much we'd pay towards the lease after 4 years. So this is part B. F of 4 is going to be $1,200 plus $350 times 4. Let's see. I'm trying to do this in my head. $350 times 2 is $700. So times 4 would be $1,400. So it would be $1,200 plus $1,400, which is $2,600. That's how much you'd pay on the lease. And it's then telling you after those 4 years, you then would just have to, so that's what you're paying on the, why can't I speak? That's what you're going to pay towards the lease over the 4 years. And, oh, shoot. Let's back up. Okay, sorry, Riley, I messed this up. I did 4 months, not 4 years. Sorry, let's back this up. I was like, why is it so cheap? I was doing years, not months. 4 years is 48 months, so it should be times 48. So it should be $350 times 48, which is a lot bigger. So let me do that. I'm going to do that on my calculator, actually. So $350 times 48. Okay, that makes more sense. I was like, gosh, this is a heck of a lot cheaper. Okay, so that would be $16,800 plus $1,200 would be $18,000. Okay, so towards the lease would be $18,000 for 4 years. But then you still would have to pay $10,000 towards the car. So to get the car, doing this lease process, it would be the $18,000 plus an extra $10,000, which would be $28,000. Well, that's looking more expensive than just buying it outright. The key is it's saying, this problem is saying, assuming no other costs. There actually is an issue with this problem because, well, actually I won't get it. It's an economic issue. But if I were just looking at this right here, I would say that it would be cheaper to buy outright. So I would say buy versus leasing. You're going to spend more money if you lease for 4 years and then spend $10,000 to then buy it outright. So I would say buying was only $25,000 versus the lease option, and then buying would be $28,000. Okay, hopefully that made sense.